A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm the same. Thank you. Monica, thermal low is basically a low pressure created due to thermal conditions, that is heating. A thermal high will be a high pressure created due to thermal conditions, that is cooling. So if in we talk about very cold areas, they will have a high pressure. If we talk about very hot areas, they will have a subsequent low pressure. But this low pressure and high pressure are induced because of temperature and hence thermal low and high. Air pressure, atmospheric pressure, more or less same. Kishan, are you sure it is not katabatic wind that you are getting confused in? Samarjit, just read as much as you can and slowly and steadily work on your communication. It improves with time when you read as many sources as you want to. When you read as many newspapers as you want to, it will happen. But gratitude for the kind words. You have been very kind. Now, hello, a very warm good morning to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to another session of climatology, where we shall be moving ahead with the portion of air circulation. But today we shall be concentrating upon the local winds, and then eventually moving ahead with the next module. So, here, what is it that we had discussed yesterday? Yesterday, we had discussed the concept of what do we understand by pressure, atmospheric pressure. So we had seen that the air which is present above the surface does impose a weight on the ground surface, and that weight indicates the presence of pressure. Now, that pressure can change over a period of time, can change within a few hours, can change within a few days. Now, that pressure is never consistent. Now, pressure in itself, we have seen, is dependent on multiple factors. One of the factors can be temperature, where it might happen that, let's say, an area gets absolutely and intensely heated up. Warm air above that region might start rising, creating a kind of a low pressure. Whenever we have a rising air column, due to whatever conditions or due to whatever reasoning, whenever we have a rising air column, that always ends up creating a low pressure. Whenever we have a sinking air column, that invariably will create a condition of a high pressure. That is something that we have seen yesterday. Now, basically, in that case of pressure, we have also seen that wherever we have a condition of high pressure, in a way, it can also be referred to as the presence of excess amount of molecules or air particles. Now, thereby, in the region of low pressure, we have very few particles or a condition of deficiency of air. So we have seen that air always will move from a portion of excess and surplus to a portion of deficiency. And that is where we have the air movement that we end up experiencing. And that is what we refer to as winds. So when we talk about wind movement is nothing but the movement of air from a region of high pressure to a region of low pressure. We have seen that wind always blow from a high to a low. Now, after that, we had initiated the discussion about the various aspects which influence the wind movement, that is the pressure gradient force, the Coriolis force, and the frictional force. Where we saw that when we talk about the frictional force, it does influence the speed of the wind as it moves over a terrain, a land area, and it experiences various different forms of resistances. When we talk about Pressure gradient force, this is the force which initiates the wind motion. And this is created whenever there is a pressure difference. That difference of pressure ends up initiating the pressure gradient force. And that is something that we had seen, that wherever the pressure gradient force is very high, means the difference of pressure is very high, wind which will be initiated will be very strong, and the vice versa, or the opposite of it, will also stand true. Then after that, we looked at the factor of Coriolis force. And there we saw that when we have any object which moves in the case of the northern hemisphere, that object will end up bending to the right. Any object moving to the in the southern hemisphere, that object will bend to the left. And the reason for that is basically the rotation of the planet. The rotation of the planet induces differential rotational speed at different portions. That means as we move from one region to another, we are moving from one particular rotational speed to another particular rotational speed. So as the object tends to move, it either ends up falling ahead or ends up falling behind. So that is why we have the Coriolis force. Now, after looking at all of these, we understood the reason why the air circulation happens. And there we saw that air circulation primarily happens. Why? In order to distribute heat, because different regions of the planet, they get heated at different rates. So that is why in order to distribute heat from the higher latitude to the lower latitude and vice versa, that is why we have the air circulation. Now this circulation, initially, first model of air circulation was provided by Hadley, and that was referred to as the unicellular model of circulation, where when we talk about the unicellular model of circulation by Hadley, it talked about only the pressure zones created due to temperature conditions. And Hadley proposed and postulated that at the region of equator, you will have an excessive low pressure due to heating, due to which the air will rise. It will sink in the region of the poles, which is very, very cold, and will have a high pressure, and hence you have the attainment of a circulation. That was the unicellular model of circulation. It had its own drawbacks and basically was absolutely flawed, so it was discarded. And then after that, we had the tricellular model of circulation, which came into existence. In the case of tricellular model, we see that you have two important pressure zones or pressure regions created due to temperature. One at the area of the equator, that is a low pressure created due to heating, and that is also what we refer to as the ITCZ. And the other pressure zone is created at the region around the poles, and that is because of excessively cold conditions, and that creates a high pressure. So in between that high pressure at the poles and the low pressure at the equator, we have a circulation, but in between them, we have two dynamic pressure zones created as well. In the case of tricellular model, we saw that around the region of equator, the air heats up quite significantly and then starts to rise up. It rises up, reaches the level of tropopause, and then diverges, moves towards the northern and the southern hemisphere. There we also observed that eventually as the air moves in the upper atmosphere, it will also have significant amount of deviation. And as a result of that, you will have an accumulation of air around 30° north and 30° south, where eventually the air will start to sink. It sinks, and due to the sinking property, it will create a high pressure on the ground, which is a dynamic high pressure. That is a subtropical high pressure belt, which is also referred to as the horse latitudes. And from these areas of the horse latitude, now that the winds are sinking and hitting the ground, they will be diverting in all directions. One will be going towards the equator, fulfilling the vacancy created at ITCZ, whereas the other one will be moving towards the polar area. And meanwhile, that wind which is moving towards the polar area will collide with the cold polar winds generated due to the high pressure at the poles, and they will end up colliding and rising up at region around 60° north and south latitude, creating a subpolar low. Now, these pressure zones, they induce the movement of winds on the surface. There we saw that we have different types of winds. For example, around the region of equator, both north and south hemisphere, that is from subtropical high or the horse latitudes to the ITCZ, you will have the movement of the winds which are referred to as the trade winds. Then beyond that, between the horse latitudes and the subpolar low, you will have the presence of winds which are referred to as the westerlies. Then from the polar high to the region of subpolar low, you have the movement of winds which is referred to as polar easterlies. So that is something that we have basically looked at, and that is the portion that we have covered till now. Today we will initiate the discussion from the portion of local winds. Okay, right? Now, here, before we initiate the discussion of local winds, you have to understand that why is it that we refer to the winds we have studied till now as planetary or permanent winds. We have referred to that, or they are referred to as planetary or permanent winds because of the reason that not only are they prevalent across the entirety of the planet, they are also continuous throughout the year, hence permanent winds, and also planetary because they are present across the planet. Now, we also have certain types of winds which are not to be found everywhere across the planet, which are to be found in very specific regions of the planet. And we also have certain winds which are in existence only during certain part of the day or during certain part of the year. Now we have seen that. So that is basically where we have to understand that these are the winds which are referred to as local winds. So local winds, as the name suggests, is localized characteristic, a localized phenomena, only in one part of the world, and that too only for a certain time period, not endlessly. So that is where let us analyze the portion of the local winds. Elias, yes, dynamic pressure, temperature can be high or low. And Chetana, uh, if you have to study geography as an optional, we cover around 55 to 60% of the optional studies here itself. So you will still have to study around 30% more. 35% more you still have to study. So, temporary, localized in a region. Temporary phenomena and localized in a region. Now, here also, you have the characterization of the winds can be done on the basis of whether these winds are, let's say, seasonal in nature, right? Whether these winds are seasonal in nature. For example, Lu. For example, Phone, Chinook, Mistral, Blizzard, right? These are our seasonal winds. And there are many of them, Harmattan, Sirocco, so on. You have many of them. The entire list will be provided to you. Okay. And then we have the daily local winds. The winds which occur on a daily basis. So here we have land and sea breeze, mountain and valley breeze. These occur on a daily basis. So here, how do you have to approach this portion of local winds? To what extent should you go into the detailing of the local winds from your exam perspective. So for this, it is generally asked in the prelims, generally, even though you can frame a question of means from this aspect, but generally asked in the prelims. And in the prelims, you get questions in the aspect of type of local wind, that is whether it is a cold wind or a warm wind. And then the region where they are found. So just take a look at these two types, and that is basically all that you need to know from your exam perspective for your prelims. Okay. In the mains at max, the important ones out of them, for example, phone or Chinook, might be asked in the mains exam, but the probability is very, very abysmal in the case of general studies. In general studies, if at all they will ask you, they will ask you in the prelims exam, right? So that is something that we will take a look into. So we start with, first of all, the daily winds. The winds occur in the daily or on the daily basis. So here we start with the land and the sea breeze. Now these land and sea breeze, this is initiated because of thermal difference in terms of heating and cooling of the land and water. So this is initiated due to thermal difference in heating of land and water. Okay, land and water, they get heated at a different rate. As a result of that, they end up finding a kind of a different pressure development. There's a pressure difference which gets created, a pressure gradient gets created. How does that initiate a wind motion? How that pressure gradient gets created? Let us take a look at it. So basically, during the daytime, we do know that land gets heated at an extraordinary rate, whereas the water doesn't get heated at the same rate. The land significantly heats up, significantly warms up, and as a result of which, the temperature over the land will rise up, will shoot up. Now, when the land heats up at a very high rate, it creates a temporary low pressure over the region of the land. It creates a temporary low pressure over the region of the land. Meanwhile, the water body, which is comparatively cooler, will end up developing a comparative high pressure. It is comparative low pressure and a comparative high pressure. So that comparative high pressure will initiate a wind movement, and that will move towards the low pressure. Wind always blows from a high to a low. So that will basically end up moving towards the low pressure, where it will rise up, form clouds, cause rainfall. Now, the winds are oftentimes named after the direction or the region that they originate from. Now, in this case, because the wind is originating over the sea, hence it is referred to as a sea breeze. Now, what is a breeze? So basically, even the wind that you have, that we receive, it is not always going to be experienced, and it is not always going to move at the same velocity. The wind in itself has different types of velocities that it will exhibit. Sometimes you might have a very feeble, a pale kind of a wind, where it is hardly something which is observable or noticeable. Sometimes the wind speed is such that it is pleasant enough but not disturbing. Sometimes the winds are much stronger. So accordingly, you have the classification of the winds, which is done based upon that. And you have the breeze, the wind, the gale, the storms, and that is the classification. Breeze is the lighter form of that wind movement. So here, when we talk about the wind, so here this wind is generated from the high pressure on the sea to the low pressure on the land, bringing some rain maybe during the afternoon, late evening on the land areas. That is why whenever you would have experienced that you have gone to a coastal area or a sea coast or a sea beach, you will find that during the afternoons and early evenings, you will observe that there is a very soothing wind, a kind of a wind which moves from the sea towards the land. So it is on your face if you are facing the sea. So that is your sea breeze. And then during the night time, you have a different condition, a reversal of condition, in the sense that during the night time, it is the aspect of losing temperature. So water loses temperature much slowly, land loses temperature much quickly. So as a result of that, land becomes a region of high pressure, whereas water ends up still retaining some heat, becoming warmer or remaining warmer, and that will become a region of low pressure. So in the night, the wind will be initiated from the land to the sea, and that is what is referred to as the land breeze. That is land breeze. So here, this land and sea breeze phenomena is a very restricted phenomena, where you have this being restricted to a very small area. This is not something which you will find extending across hundreds of kilometers across the coastline. Only if you observe here also, this entire phenomena spans only around 50 kilometers from the coastal area around it. So it is a very small and localized phenomena for that sense. And this is observed during the day. This is observed during the night. Then another daily phenomena that we come across is the case of mountain and valley breeze. No, onshore and offshore are similar, but they are very different from land and sea breeze. Onshore and offshore winds that we refer to, we are talking about large set of prevailing winds in the sense of permanent wind setup, which are created. Land and sea breeze, very temporary phenomena. Then we come to the portion of mountain and valley breeze. Now, this is also a daily phenomena in the sense that during the daytime, because of higher insulation, you do have a condition where significantly the top portion of, let's say, a hill or a mountain significantly gets heated up. Now, as it gets heated up, you will have the development of low pressure in this area. Now, because of that low pressure, you will observe that the winds are driven from the valley towards that low pressure. From the valley towards the low pressure. And this is what is also referred to as valley breeze. That is what is also referred to as the valley breeze. And because it is initiated due to the winds which are originating from the valley and moving atop the hill or the mountain where you have the development of low pressure. This will be observed during the day. During nighttime, things will reverse in the sense that when the sun is not shining anymore, the top of the mountain will or the hill will cool down at an extraordinary rate at a very high pace. So as it cools down at a very high rate, it develops a high pressure in this area. A significant high pressure is developed. And then the valley bottom is comparatively warmer, due to which you have winds which originate from the mountain top and which move into the valleys. Now, because they are originating at the mountain top, they are also what is referred to as mountain breeze. Mountain breeze. Yes, Tajinder, due to high insolation, that is why it creates a low pressure region on the top of the or on the top portion of the mountain. Shalu, because of higher amount of insolation which is experienced, that is why that acute low pressure is created. Now here, when we talk about this mountain breeze, it is experienced during night time. Okay, so that is basically again occurrence on a daily basis. That is what we have as the mountain and valley breeze. So both the land and the sea breeze, as well as the mountain and the valley breeze, both of them, you will observe that there is a kind of a daily reversal of wind direction because of the fact that you have development of high pressure and low pressure due to different areas getting heated up. So, for example, in the land and the sea breeze, we have seen that land areas will get more heated up during the day, development of low pressure. So, the winds will be coming towards that low pressure, land breeze, reversal during the night time. The land will be very cold as compared to water, hence, the case of land breeze and sea breeze. So, sea breeze during the day, land breeze during the night. And then after that, we had seen that in the case of mountain and valley breeze. So when you consider top of a hill, a top of, let's say, a mountainous area during the daytime, it will receive very high amount of insolation. And due to that high amount of insolation, we will experience a development of a low pressure on top, due to which the winds are driven from the valley to the mountain top, creating a kind of a valley breeze. And during night, the top of the mountain will lose heat very substantially and at a very high rate, due to which there will be cold conditions, development of high pressure, and movement and origin of the winds, which is the mountain breeze as it is referred to. Okay, now here, after this, we come to the seasonal winds. Seasonal winds, when we talk about, first of all, the Lu. Now, Lu is a wind which exists in the northern part of the country, in particular to the north of Tropic of Cancer. During these months, that is the end portion of May and June, that is when you have a very warm wind which moves from west to east, a very warm and dry wind which moves from west to east. And that is what is referred to as Lu. So it is experienced generally during late evenings, late afternoons and evenings, after the land has gotten sufficiently heated up. So it moves through the region of west to east. It brings, or it becomes dry as it moves over the region of the Thar Desert. And that is why it creates oppressive conditions. So it is hot and dry wind, which blows very strongly over the northern plains of India and Pakistan in the months of May and June. Their direction is from west to east, and they are usually experienced in the afternoons or early evenings. Many of the times, their temperature basically will end up varying in between 45 degrees to 50 degrees Celsius. And that is why it is always thought to be very dangerous. Why? Because when the Lu is in motion, suddenly the temperature increases, and because of the dry conditions, the lack of humidity, it will have its debilitating impact. That is why you would have observed, if you have lived in these areas, you would have observed that in your childhood days, no one would allow you to get out of your house in the late afternoons during the summer, that you will be impacted by Lu. So that is the condition of Lu, originating in the region of uh, Balochistan and Sindh region in Pakistan, moving eastward, it becomes dry. Okay, so west to east and hot wind. This is the property you have to keep in mind. Then we have another local wind that is in motion in the region of northwestern part of North America, that is across the Rockies. Now, if we recall the map of the Rocky Mountains here, if let's say we recall the yes, these are your Rocky Mountains, isn't it? These are your Rocky Mountains. Now, in these Rocky Mountains, you will have a western slope, you will have an eastern slope. So, across the eastern slope of the Rockies, you have the wind which is in existence. That is the wind that we refer to as Chinook. So, what is that wind? How does that wind become warm and dry? So, this is also warm and dry wind, but not warm and dry to the extent that when we talk about Lu. Lu, when we say it is warm and dry, it has a temperature of 45 to 50 degrees Celsius. In this case, when we say warm and dry, it might even have a temperature of, let's say, around somewhere around 5 degree, 10 degrees Celsius, and even that can be considered as warmer because the surrounding land areas, they are going to be very, very cold. So that is where we here when we talk about warm and dry winds. So why are they warm and dry, and how is it that they impact the local environment? So here, think about this as the Rocky Mountains. Here we have the west. Here we have the east. Now, in this case, as the wind moves up, here, the wind as it rises up the slope of the mountain, that is where the wind starts to lose temperature. It becomes very cold and it forms a cloud, which eventually will cause rainfall. Okay? So, here basically, the side which faces the wind, there the wind will rise up. It will lose the temperature as it rises up. Now, as it rises up, it loses temperature, becomes cold, and then brings rainfall. Now, the wind which will appear after that, here, what do you think will be the amount of moisture present in that or water vapor present in that? The amount of water vapor now left in the wind will be very less, almost negligible, because all that water vapor has been utilized to bring rainfall. So now this wind is dry. And then, owing to the slope characteristic, this wind will come down the slope here. But as it gets down the slope, can we say that it is moving from an area of lower air density to a region of higher air density? So as a result of that, this wind will experience some amount of compression. And due to compression, there will be warming. So here you will experience adiabatic compression to happen. Adiabatic compression to happen. And that brings about an associated heating. And that is why the wind that you observe on the slopes, on the foothills, that will be warm and dry. That will be warm and dry. And as a result of that, as the wind is warm and dry, it will lead to melting of snow in the lower reaches of the eastern slope of the Rockies. And that is why it is also referred to as snow eater. Melts the snow and hence is referred to as snow eater. Okay, so that is basically the characteristic of it. So here you will observe that again I will reiterate the entire process. So here if you think about the Rocky Mountains, Rockies, as the wind approaches the mountain, due to the physical barrier which the mountain provides, the wind is forced to rise up. As the wind rises up, it will expand. There is an adiabatic expansion. Why? Because from a lower height, it is moving to a greater height. And higher that you go, the density of air reduces. So the air which is rising up will always tend to expand. So here, as the air is rising up, it will expand, lose its temperature, form the clouds, and bring heavy rainfall. But after that, the air which is left over, that is going to be absolutely very dry. And this leftover air then, as it starts sinking, that leftover air after that, which is also dry, as it is moving down the slope, it is moving from an area of low air density to a region of higher air density, because closer to the sea level, the air density will be very high. At a higher altitude, the air density is very low. So as the air is moving, it will get compressed into the region of higher air density, as a result of which you have the creation of warming due to adiabatic compression. You have heating or warming, and hence the temperature goes up, which melts the snow in the region, and that is why it is referred to as the snow eater. Now here, the portion of a mountain or a portion of a hill, even any physical barrier, if you consider the portion which faces the wind directly, that is the size, shape, or that is the region or the zone which is also referred to as the windward side. Windward side. Now, the portion which is away or the opposite side of where the wind is coming from, that is the one which generally lacks rainfall, doesn't receive rainfall because of the dry winds, etc. And this is what is referred to as the leeward side. Okay, so always windward you will observe to be significantly rainier areas, and leeward side you will always observe in all the mountainous areas, all the hilly regions, that leeward side is going to be the drier region. That is why leeward side is also what is referred to as the rain shadow zone. That is, in that region, you don't experience rainfall significantly. So it is the wind, Chinook is the wind moving across the eastern slope. Then after that, here, you observe that the Alps are here in this region. Now the Alps will not have an eastern or the western slope. Alps will have a northern slope and a southern slope. So just like the case of Chinook, here also you will have a warm wind which is in motion. A warm wind which is in motion on the northern slope. And that is what is referred to as foehn. So that is what is foehn. Very, very similar to Chinook. Here also, the only difference is rather than eastern and the western slope, here we will consider the northern and the southern slope. So if you consider the alpine mountain ranges, right? If you consider them, Now, as the wind comes here, the wind rises up. Okay. It will bring rainfall across the windward side. Then the wind will get drier. It moves across the northern slope in this case. As it is coming down the slope, it will get warmer because of adiabatic compression. And there in the alpine region, it will provide. Here, this is the southern slope. And this will be northern slope. This is the region of Alps. So in the alpine region, what you will observe is that the presence of these winds, they will provide a kind of a favorable climate, a pleasant climatic condition as the wind starts to sink and warms up. In these areas, the climate is moderated, otherwise which would have gotten very cold. That is why it is also referred to as a climatic oasis of sorts. I hope we understand the meaning of the term oasis. Oasis basically is the small pool of water that you find in the middle of the desert, right? So oasis is always referred to as a symbol of relief, because when you find water in the middle of the desert, that is as good a relief as it can get. So that is why it is referred to as a kind of climatic oasis. Fohn is referred to as a climatic oasis. So it is a warm and dry wind like Chinook, and it moves across the northern slopes of the Alps mountain. And during the month of spring and autumn, that is between the season change from summer to winter, winter to summer, during that time, it is more prominent. Weather becomes quite pleasant in the valleys of Switzerland due to the melting of snow. And why does the melting of snow happen? Because of the fact that you have the warmer winds which are moving down the northern slope. So, therefore, valleys of Switzerland are called climatic oases, particularly during the winter months. And as the temperature is warmed and moderated significantly, these winds they help in sowing of wheat, ripening of grapes, and also prevent the formation of frost during the autumn season. So that is the characteristic that you will observe in the case of Fohn. Okay. Now, after that, so both Chinook and Fohn, the same characteristic. Then let us take a look at the cold seasonal or the cold local wind. That is Mistral. Now, Mistral is in existence particularly during the winter season over the region of Europe. So, that is where Mistral comes in existence. It is a cold local wind, especially during the winter season. So, what the characteristic of this wind and why this wind will come into existence is that you will observe during the winter season, land gets very cold. As the land gets very cold, water comparatively ends up staying warmer. So the land gets very cold, develops a high pressure. Water is comparatively warmer, develops a kind of a low pressure. So as a consequence of that, when the land gets cold, there will be a development of wind movement towards the low pressure. So wind is initiated from land to the water, that is from a high pressure to a region of low pressure, and that is what is referred to as Mistral. So high pressure over Europe and low pressure over Mediterranean Sea during the winter does initiate this wind motion. And because this wind is coming over from the very cold land areas, the oncoming wind will suddenly cause a significant drop in temperature, will make the conditions much more oppressive. That is the characteristic that you associate with Mistral. Then we have another cold local wind, and that is referred to as blizzard. Now, this blizzard basically would be observed in the cases of the extremely northern latitudes. That is, when we talk about the northern part of North America, northern part of Europe, northern part of Asia, it is in that region, that is Siberia, Europe, Canada, and even United States, that gets impacted by this very cold local wind, which brings about colder conditions. And it is also specially observed during the winter months when the land does get very cold. And as a consequence of that, when the land does get very, very cold, you will observe that the wind starts its motion. Winds will move from the higher latitude. They will be carrying that powdered snow along with them. They will cause substantial lowering of temperature as well. So it is a violent, stormy, cold, and powdery polar wind laden with dry snow and is prevalent in North and South polar regions, Siberia, Canada, and the United States. Now, the visibility becomes remarkably low because of snow and ice crystals that the wind is able to carry along with them. The velocity of the winds is as high as 80 to 96 km per hour, and these winds cause the sudden drop in air temperature to sub-freezing level. Thick cover of snow is created. So here, observe this. Here, observe in this particular map, if you are careful enough, that there is no east to west mountain range in this area, unlike the case of Himalayas, right? Himalayas are east to west. So the Himalayas are able to prevent us from any cold seasonal wind which might originate from the region of Siberia. But in this case, you don't have any east to west mountains. As a result of which, when the cold winds they come and they originate, they are able to influence significant portions of United States as well. And that is why United States is also impacted by blizzards. Okay, if there would have been an east to west range, only Canada would have been impacted. United States would have experienced much more pleasant conditions during the winter months. And this blizzard, oftentimes, it has got very debilitating impact. Every year it tends to claim many lives in general. In the case of blizzard, you will observe that they tend to claim many lives, because these winds, they will have no visibility, or they will create a condition when the visibility is absolutely close to zero, because the winds will be carrying that white powdered snow, and the temperature will drop very significantly. It can suddenly become -5, -6 degrees Celsius, -3 degrees Celsius, and that will lead to immediate hypothermia, and a person can basically get impacted by that. So oftentimes you will find that homeless people in the region of United States, they get impacted by this, and overall that is where we have the impact or influence of blizzard which caused a lot of deaths in US last winter. So in US, you also have the characteristic of a polar vortex which comes into existence sometimes due to stratospheric conditions. So that is also something which causes sub-zero temperature suddenly. But then this blizzard is when you observe a strong wind movement with a lot of small or whitish snow being carried. That is blizzard. That also claims a lot of life. How snow is dry, as in the snow is, when you have this wind carrying that snow, very fine particles of snow, it is generally dry, right? When we say the snow will not bring moisture with along with itself, that is always, that is why it is referred to as dry snow, the powdered snow. So if you ever experience that, it is very akin to the just the fact that it will be absolutely deathly cold. But just like when you are in a kind of a sandstorm, you will get almost a similar feeling. The only aspect is it will be absolutely very cold. You will not be able to see anything, and wherever it will basically hit your face, that is where you will have a kind of a burning sensation, that as if that skin has burnt off because of the very low temperature. Okay, so that is basically the dry snow. Where will be the low pressure of this wind? So it is basically, Ravindra, driven by the extreme high pressure developed in the polar areas due to very cold conditions. That is where it tends to develop in certain cases. Nisarga, how can Lu generate heat wave or contribute to heat wave? Not very significantly. When we talk about Lu, it can happen on a daily basis, on a kind of a weekly basis, but heat wave characteristics will be associated with the occurrence of rainfall. The occurrence of drier condition, that is what will initiate the heat waves. So when you have the region not receiving any rainfall for a very long period of time, the ground also becomes very dry. That is when you start experiencing heat waves, not just the periodic movement of low. Okay. Mountain breeze induced situation like temperature inversion, yes. In which season Chinook will occur? Chinook also is observed, especially during the time of spring, is when you will observe the movement of Chinook. Spring, winter, that is where you will observe. But mostly, immediately after the winter season, you will observe that melting of snow to happen, and sometimes even before, immediately before winter as well. Very similar to kind of phone that we saw. How the Bhavna, how the west to east mountain range changes the blizzard effects? There is no west to east mountain range in the region of North America. So there will be no impact on blizzard because of any of these. Okay. Mistral is similar to Chinook? Absolutely not. Phone is similar to Chinook. Mistral is not. Yatendra, why the wind is from south to north in Alps? As per northeast subtropical wind should be north to south. No, even if you consider that logic, in that region you have the presence of the region, or that region of Alps is beyond the subtropical high, so there normally you have the presence of westerlies. But these local winds, they are not a part of permanent wind system. Please understand, local winds are not at all a part of permanent wind system. Local winds are generated due to localized pressure difference which is created. That is where you have the local winds getting generated. Okay. Mistral is generated during the winter months in the region of Europe, when you have excessive amount of cooling or cold conditions creating a high pressure over the land, whereas water which is comparatively warmer develops that low pressure, due to which you have the movement from land to water in the cold winds. Phone is very similar to that of Chinook. When we talk about phone is basically a wind which drains, which moves again from south to north in the case of the alpine region. And that again is generated because of the localized pressure difference in that area, but more so exaggerated during the spring and the autumn months. And that is when the winds will cross the mountain, when they will come down the slope, they will create some sort of warming, and that is what is referred to as phone. Local wind can be affected by permanent wind. So generally, where you have local wind in existence, you won't find the permanent wind system to be very active at that point of time, because please understand, it is not as if you have different governing bodies for both of them. One will implement local wind, one will implement permanent wind system. No, both of them operate based upon the difference of temperature. So wherever you have a substantial difference of temperature, wind will move. Now if that difference in pressure is created throughout the year, you will have a perpetual movement of wind or a permanent wind. If you have a localized pressure difference which is created, then you will have a local wind. Okay. Now, then we have Sirocco. Now, Sirocco is a kind of a wind which originates from the region of northern Sahara, moves over the region of Mediterranean, and then hits the region of southern Europe, bringing rainfall in southern Europe. Now, this is also warm, dry, and dusty wind in general. Now, here, as this wind moves over the region of Sahara, it picks up that very dry, dusty red sand along with it. Reddish sand, as it is picked up, the wind blows. It crosses the Mediterranean. As it moves over the Mediterranean, it will pick up moisture from the Mediterranean. And then the wind now will be laden with moisture as well. So after that, when it will hit the European coastline, it will cause substantial amount of rainfall in the region of Italy and the southern parts. Now there, when it brings rainfall, along with that, it also starts dropping the red sand that it had been carrying. So that is why the rain droplets, they give that reddish tinge, a reddish appearance, which appears as if there is blood. Hence, it is referred to as blood rain in these areas. Because the sand that it carries from Sahara, moisture that it carries from Mediterranean, both of them are mixed, and then the rainfall which is caused in the southern slope, that is what is referred to as the blood rain. Okay? And that is associated with Sirocco. So these are few of the local winds across the entirety of the planet. And you will observe there are a lot of them, in fact. So for example, here you have the blizzards, as you can see. Here is where you have the Chinook. Here is where you have the Fohn. You have Mistral, Sirocco, Khamsin, Harmattan, Bora, all of these, Berg, Pampero, all of these are basically different types of local winds. I have given or attached an entire list of them and a basic characteristic of them for various different continental areas. Just go through them and thereby get an idea about it. So, just for your prelims purposes, you should be aware that what are the winds present in North America, winds present in South America, winds present in Africa, each of them along with their characteristic we have attached, and that is for your perusal and your reference purposes for your examination. Okay, now after this we come to the portion of humidity and precipitation. Sirocco winds are raised from India only? Absolutely not. Sirocco is raised from the northern portion of Africa. You don't have the presence of Sirocco in the region of India. Why did you think it will be originated from India? So now we come to the portion of humidity and precipitation, where we talk about what do we understand by humidity, what are the various measurements of humidity, what do we understand by precipitation or rainfall, what are the various different types of clouds which are experienced, what are clouds, how is it that the clouds are created, why is it that the rainfall occurs and in some areas we experience snowfall. Certain regions, they experience the occurrence of hailstorms where you have large ice particles which start falling on the ground surface. So all this we are going to study, the fog, the types of fog, cloud burst, what they are. These are the things that we are going to study here. Chinook. Okay, what is the meaning of Chinook, by the way? Where is the word Chinook taken from? Any of us, if we have a clue? Where is the word Chinook taken from? Chinook, have you heard before that? Yes, good. Oh, no. Please don't. Chinook is the local tribe, the local Indian tribe that you find there, right? The in the region of North America. That is the local indigenous population, that tribe. You have many of them One of that is Chinook. And that is where you also have the name associated with a kind of a helicopter, a kind of a lift helicopter, a cargo lift helicopter, which Indian Air Force has also imported. That is Chinook. Okay. A few weeks back, we had a kind of a a kind of an emergency landing carried out by Chinook also. So please at least adhere to the portion of current affairs. You cannot ignore current affairs in the present day pattern of civil services. All these you will get an idea. So if you would have been looking at current affairs, at least we would not have had guesses that Chinook is a Hindi word or a Chinese word. It is not from this region. So here in the prelims, the questions that you get: basics, measurement of, or rather, how is it that humidity is measured, in the sense that we express humidity in sometimes the condition where we measure the weight of water vapor and the weight of air. Sometimes we measure the weight of water vapor in the volume of air. Sometimes we experience or we end up measuring what is the water vapor present as compared to the capacity of air. So that type of humidity. So absolute, specific, relative humidity. Then types of clouds. Then after that, types of fog. Okay. These are basically conditions required. These are basically the areas from where you can expect questions in the prelims. And for the mains exam, you can expect question from the region of cloudburst, hailstorms, okay, cloudbursts, hailstorms, types of rain, a question once in this was also asked from the portion of thunder and lightning. So that can also be included. Okay. So this is the area from where you can expect a set of questions to be asked. Now, by the way, before proceeding ahead with the portion of humidity and precipitation, let me give you a kind of a practice question for your mains exam from the previous module. Practice question. I hope you'll be able to write the answer of it. Creation of pressure zones is is an outcome of not only the factor of temperature, but also the movement of air. In the context of the above statement, analyze the formation pressure zones. Also, discuss the possible movement of winds from the, the pressure zones with the help of tricellular model of circulation. So I hope, first of all, when you take a look at these long questions, I hope, first of all, you are able to understand the requirement of the question. The requirement of the question in this case is to analyze that how is it that dynamic pressure zones and thermal pressure zones are created. Why? What are these dynamic and thermal pressure zones? Where they are in existence across the planet. Once you have associated that, or once we have talked about that in the answer, after that you have to talk about the winds which are in existence across the planet, and that is where you have to talk about that how is it that these winds are initiated with the help of tricellular model of circulation. So that is where you have to talk about the entirety of tricellular model of circulation. Diagrams needed for tricellular model? Absolutely yes, my dear friends. Please never have this hesitation. Again, I will reiterate the same thing that I have been repeating from first session. Any answer of geography, if it is without a diagram, that portion of or that answer is rendered to be incomplete. Minimum one diagram, right? Minimum. There can be 2 to 3 diagrams in certain answers, but minimum there has to be one diagram. Okay, so please never have any answer of your geography portion without the diagram, especially if it is coming from the portion of physical geography. You do need the presence of, or you do need the depiction with the help of the diagram. So, any of us having any problem in this question? Diagram words are not counted in 250. No. Okay. No doubt. Lakshmi, you have a doubt? So basically here, see, what is the question? The question is that creation of pressure zones is an outcome of not only the factor of temperature, but also the movement of air. And we know that the movement of air can initiate the formation of a dynamic pressure zone. So here, that is what the statement is talking about. So the statement is referring to the creation of dynamic pressure zones. In the context of the above statement, analyze the formation of thermal and dynamic pressure zones, right? So how is it that a thermal pressure zone is created? Due to heating of the land, Due to conduction, the air above it also gets heated up. That air then tends to rise, and rising air will create a low pressure. In a region where you have very cold conditions, the air will also get colder. As the air gets colder, materials get together, they will sink, creating a high pressure. That is a thermal high pressure. Then you have to talk about the dynamic low pressure and high pressure. When you have convergence of winds in a region, they have no other place but to rise up. That is what is referred to as a kind of a dynamic low pressure and a dynamic high pressure. Then you can write that this dynamic pressure zones are experienced where, and thermal pressure zones are experienced where across the planet. We do know that thermal pressure zones are experienced at ITCZ and at the region of the poles. Dynamic high pressure zones are experienced at subpolar region and subtropical high, and that induces a kind of a wind movement. Then here the second part is discuss the possible movement of winds from the pressure zones. So in that case, draw the entire tricellular model, depict the pressure belts, talk about why is it that the wind is circulating from one region to another. Very briefly talk about these winds, write a particular subheading about each of the pressure zones, a couple of sentences, and your work is done. Any doubts which prevail? How to write definition? You don't have to write definition at all. Nowhere in the answer should you write definition. Please understand. And that is what I have been saying, that you don't need to learn the definition ever. If you are learning a definition for something, means you are creating a scope for causing mistakes. Please don't learn the definition. Whatever you are able to understand, express that. That is the crux of answer writing. Remember, we had discussed the entire process of answer writing, that what needs to be followed in the first week itself, that what should be the basics to keep in mind in the answer writing. So here, for example, in the introduction, when you write, introduction should follow directly from the main demand of the question. What is the main demand of the question? The presence of a dynamic pressure zones. So here in the introduction, when you write, when you are writing the process or the aspect of introduction in this case, just talk about the fact that the creation or the atmospheric pressure in a region can vary significantly above and below the average, creating low pressure and high pressure. Across the different parts of the planet, this low pressure and high pressure regions can be created either due to heating or cooling of the land, or due to the creation of the rising air and sinking air column because of convergence and divergence of the wind. That is what is referred to as the dynamic pressure zone. That marks the end of your introduction. From the body portion, then after that, you start talking about it, that what do we understand by the thermal pressure zones, how thermal pressure zones are created, how is it that the dynamic pressure zones are created. Draw small schematic diagrams. Never be afraid to draw small schematic diagrams. Draw them maybe on the side of the paper or the answer, maybe in between. And after that, come to the second part about the tricellular model of circulation. Write about it. In the conclusion, when you write, you can talk about the fact that these pressure belts and zones which are created across the planet end up providing the continuous movement of wind throughout the year. With the shifting of the pressure belts between the seasons, the winds also tend to shift. These winds overall are offshore or onshore in nature across major parts of the world, influencing the local climate, vegetation, and also the life lived. And this is also responsible for the seasonal variation in climate, temperature, and so on. So that is where you can end the session, end the basic answer. Okay. Yes, you can draw the diagram with the help of the pen also. Ocean, I generally mark parts of diagrams as A, B, C, and then write about it like what is called below the diagram. No, see, please understand. First of all of you who are saying that will it be counted in 250 words? Please understand, it is not as if that out of 250 words, if that is the requirement, if you are writing 252 words, then marks will be cut. No. Anyways, you have 10% scope. That is 250, you can carry it on to 275, but that is still not in the GS answers. The answer, you will have a space designated for the answer. You have to write the answer in that designated space itself, right? So be mindful that any answer will add around 15 marks, should be around 2.5 pages, and that is it. Okay. And please show the rough diagram for this practice question. For this, you can have many of the rough diagrams. One of the rough diagrams can be of the thermal high pressure which is created. Here you can talk about heating of the landmass. Let's suppose a region gets heated up. So indicate here heated land, indicate that the air gets warmed. So whatever you are writing or whatever you are drawing, rising air, creation of low pressure. Then in this region nearby, designated very cold conditions, air becomes colder, cold air sinks, right? And that creates the high pressure is created. Okay. So for that, by this image, for that example, by this image, you can depict the creation of the thermal high pressure, low pressure zone. Similarly, you can have an image of a kind of a dynamic high pressure, low pressure zone as well. So there also, if you consider, simply draw the presence or the existence of a wind movement. Or even if, let's say, you don't have to draw the entire image around a particular room that we saw. So here you can simply have a kind of a broader depiction, somewhat like this, that as the winds come in from different direction, the winds will have no other place to go, and eventually the wind will rise up. So that is why across this region on the ground, you have the rising air and you have the low pressure. So like this also, you can have a brief depiction about the dynamic pressure zones which can be created. Okay. Exertion and rising of air. Exertion and rising of air on land led to creation of pressure zone. Why exertion as a term is being used? I understand my English is not as good, but why exertion as a term? Can we not write heating and cooling of the land? I think that will also solve the purpose. How to write conclusion? So when you are trying to write the conclusion, just summarize. In these type of questions, just summarize what you have written. Please don't repeat it, the wordings of it. So just by summarization, I basically refer to the fact that, for example, in the entire process, you would have talked about the movement of the winds, the existence of the pressure zones. So there in the conclusion, you can talk about that these pressure zones end up inducing winds which influence the climatic conditions across the world. And by being offshore or onshore, they are not only determinants of the amount of rainfall, but also the seasonal variation that we experience as it is. Okay. While making notes, do we need to write definition? Definition is something that if you want, you write, but always I would suggest never end up learning a definition. Definition is something that should always be taught by yourself, and the more you write, the better it is. Okay, so you will get an idea about what do you understand by a particular point. So definition for anything, if you will remember or learn, you will end up forgetting some part of it or the other, and that will create its own set of problems. Okay, Smriti, there are so many definition based write-ups in ARM, so that is for your reading. So in the books also you find definitions, but that is because so that you can read them, you can understand them, and then you should be able to reproduce them in your own words. Shalu, in polar area there is sinking creating high pressure. In 30-degree latitude there is sinking causing high pressure. What is the difference between thermal high and dynamic high? So in the polar region, why is it that the sinking is happening? Why do you think in polar area the sinking is happening? If we know the reason, then we can understand the difference. If we don't know the reason, then for us, all the pressure zones are very similar. So the sinking in the polar region is happening. Why? Because the ground conditions are very cold. The ground conditions are very cold means what? The air above it will be very cold. The air will lose temperature, the particles will lose energy, the particles will get closer to each other, and the particles will drop, creating that high pressure. And the polar areas, they are very, very cold throughout the year, sustaining that high pressure throughout the year. When we talk about, let's say, the region of the subtropics, there, why is it that we have sinking of air? There, the sinking of air occurs because in upper altitude, in upper region of troposphere, in the region of tropopause, there is an accumulation of wind. The wind which is coming from the top of the from the top of the equator, and that wind, it is converging with another wind coming from subpolar region, and it is sinking. So that is a dynamic pressure. Thermal pressure is much more permanent in nature, particularly in the case of the poles. In certain cases, it is much more stronger as well. Okay. If I am drawing the tricellular model for this question, how to draw in minimal space? You can draw anything in as much space as you want. It is basically how big an image you want to draw. So I, I'm unable to understand the predicament here. So draw like this, as simple as 0 degree, 30 degree, 60 degree, 90 degree. Winds will come here, they will rise up, they will diverge, they will sink here. One part goes here, it rises up like this. Meanwhile, here the wind comes, rises up. As simple as that. You have the tricellular model. Now, the same model, I can take the entire screen and also I can draw here. Okay. In what way can we show way forward? This question does not have a component of way forward, Vivek. So is that clear, or any doubts that prevail? Clear? Good. So now we come to the portion of humidity. Can we draw pencils using pens? Can we use diagrams using pens and pencil? Yes. In Siddharth, I've already talked about the conclusion, my dear friend. I've talked about the conclusion twice. Intro. Jagdish, should I mention Coriolis force in this? Absolutely not. So, Siddharth, I will not repeat the conclusion again. In the case of intro, just understand what is the demand of the question. The demand of the question is basically the aspect where you have to understand. It is about the dynamic pressure zones. So, understand, first of all, very briefly, in one statement, write about atmospheric pressure. What do you understand by atmospheric pressure? So, the total pressure induced by the atmospheric conditions from top to the surface. Then, conditions or wherever you have a rising air column that creates a low pressure, a sinking air column can induce a high pressure. Now, that low pressure and high pressure can be controlled by heating and cooling of the land, but can also be induced by the collision, convergence, or divergence of the wind, creating that conditions of low pressure and high pressure referred to as dynamic pressure zones. That is it. And in the conclusion, again, I would suggest please just write the summarization of what you have written before. So, here, in the case of summarization of what you have written before, just write that these pressure zones initiate wind movement, which can influence the climatic conditions, that is, temperature and rainfall across the entirety of the world. And the shifting of the pressure belts between various seasons also brings about a seasonal variation in terms of rainfall and temperature patterns, influencing not only the natural vegetation but also the larger biodiversity or our own life. So you can talk about any of this. Okay. So yes, I think break is required, Abhishek, because even after repeating the same thing for 2 or 3 times, I think people are failing to gather that we have replied. So please take a break, wash down your face, everyone, come back again after 10 minutes, or and then we will continue again. Okay. So all of you who are basically, even after 2 to 3 revision repetitions, you are still unable to understand if we have talked about conclusion, introduction or not, kindly wash your face. We'll take a break, we will be back, and then we continue with humidity. So okay, we take a break for 15 minutes today. Done. Do we need to mention about trade westerlies on it? Yes, we do need to mention about. When you are mentioning about the pressure zones and the tricellular model, you need to mention about all of them. A confirmation about the audio, please. If the audio is clear and available, kindly confirm the same. Thank you. So now we come to the portion of climatology, which will give us an idea that why there is rainfall which occurs in certain areas. Why is it that condensation is experienced? Because in your day-to-day life also you would have come across this experience where you would have observed the existence of cloud but no rainfall. And sometimes you would also have come across the experience that there is the presence of cloud, it will cause very deep thunderous and lightning events along with it. So that is something that we need to analyze, and we need to understand that why is it that rainfall occurs, where is it that condensation will occur. So we analyze that with the property of the air itself. Now we have seen in the portion of atmosphere and the basics of atmosphere that overall, whenever we consider the constitution of atmosphere and the components present there, we will have the presence of gases, water vapor, and the dust particles as the major constituents. Now, the gases, dust particles, and water vapor, they bring about all the various climatic influences and impacts that we come across. Now, in this case, the water vapor which is present, the water vapor across the planet is not very high, in the sense that let's suppose all the water vapor present in the air, if all of them were to condense, it would end up forming a kind of a very thin layer across the planet of liquid water, only around 1 inch thick. That is all the water vapor which is present. And that much water vapor in the atmosphere is enough to cause storms, thunderstorms, cyclones, etc. So that is why it is important for us to understand that what is the constitution of water vapor. So the presence of water vapor in the air is what is referred to as humidity. Now, otherwise also, other experiences, if we talk about, you would have experienced sometimes, especially during the summer seasons, that even when you start to perspire, whenever there is perspiration happening, that is, let's suppose you start sweating. Now, during the summer season, sometimes you would have experienced that as soon as you start sweating, immediately everything evaporates. All the sweat evaporates, giving you a kind of a cooler conditions on the skin and giving you a kind of a relief. But sometimes you also experience, especially during the rainy season and later part of rainy season, that it becomes very uncomfortable, because when you sweat or once you perspire, that doesn't evaporate anymore. That stays on your skin, creating that uncomfortable condition. All of that is ascribable due to humidity. And even, for example, if you have traveled in different parts of the country, for suppose, let's say you are in a coastal area like Mumbai or Chennai or Kolkata. Now, in those areas, even though the temperature is not very extreme, but it is much more intolerable, in the sense the climate conditions are much more oppressive, in the sense that there, when you perspire or when you sweat, it doesn't evaporate. But in, let's say, Delhi, Chandigarh, Ambala, the temperature is to the extremity, 45, 46 degrees Celsius. Still, in those conditions, you won't feel a significantly very high level of discomfort because of that cooling effect. So let us understand the humidity. What is this humidity? It is influenced by temperature. How do we end up measuring humidity in various aspects? That is, the various different types of humidity in terms of the measurement aspect. And that will give us an idea about the condensation. So humidity is the content of water vapor present in an air parcel. And air parcel, air column, these terms that we will use from now on, think about it as a sample of air. Any sample of air that we take for consideration, we will consider that as an air parcel. Now, here, when we consider an air parcel, let's suppose two air parcels, A and B. And let's suppose the darker dots that you see, they represent the water vapor. So obviously, in the second air parcel, we can say that the humidity level is going to be higher. Humidity level is going to be higher. Now, when we talk about this particular humidity, here we have to understand that it is not always going to be consistent. The amount of moisture, the amount of water vapor present, that ends up getting varied because of various impacts. Sometimes even the wind movement can alter the presence of water vapor. You would have observed that sometimes, let's suppose the condition is very moist, and if there is a dry wind, then again the conditions become very dry. So the wind will be able to carry away those, right? But that is something which is very temporary. Now, here, if you have to understand at a level of the particle, understand that how is it that we can represent this humidity. So suppose we consider the gaseous particles. Suppose we consider the gaseous particles here. Now, the water vapor molecules, they can get accommodated in the spacing in between, isn't it? The spacing which is present in between the molecules. So that is where you will have the presence of these water vapor molecules. Now, overall, any parcel of air or any sample of air will have a kind of a capacity that this is the amount of moisture, for suppose, or or water vapor that it can carry. It cannot hold any more amount of moisture. So that is what we refer to as the carrying capacity of any air parcel. So when we talk about the aspect of carrying capacity, what does that represent? It basically ends up representing the amount of moisture that an air parcel can carry at any given temperature. At any given temperature, the total amount of moisture that an air parcel can carry. Now, let's suppose the air parcel that we have talked about. Let's suppose I heat up this air parcel. I heat it up in the extent that the temperature rises. Now, when the temperature rises due to heating, let's suppose the temperature rises. So all the particles will gain energy. The air gaseous molecules will, in a way, they will be escaping from one another. So when you heat it up, the gaseous molecules will be escaping from each other. So in this case, what do you observe? As compared to the first image, as compared to the first sample, here you find greater space available for the presence and accommodation of water vapor. Here you can have more water molecules which can be accommodated. Why? Because the spacing has increased, isn't it? So can we say that when we heat up the air parcel, the carrying capacity of the air will increase? Can we think about that? Can we have that conclusion? Any doubts in that? Good. So that brings us to the one conclusion that we can draw from here. Heating of air increases the carrying capacity. And why is that? That is because when you provide heat, that is providing energy to the particles. So the particles will be in motion, significant motion. Many of the particles will escape the system, and that is why you will have a greater space available. Now, converse of it, the absolute reverse of it. Let's suppose we carry out a process of cooling. Now, when we carry out the process of cooling, means what? The particles, they will lose energy. That is when cooling means extraction of heat energy. So the particles will be losing energy. So when the particles lose energy, they will get much closer to each other. Other particles outside this system will also enter in. Now, when you have the particles much closer to each other, not only does the air become heavier, start to sink, but also you have, if you observe, now got lesser spaces in between where you can accommodate water vapor. So you have, as compared to the earlier scenario, you have lesser space available. So thereby, we can have the second conclusion. Can we say that by cooling, the carrying capacity reduces? Isn't it? So we can say cooling of air. Any problem in that conclusion? Any issue, anyone? Good. So here we can say cooling of air reduces the carrying capacity of air. We can talk, we can have a conclusion like that. Fair enough. So when we now talk about the aspect of humidity and temperature, we can think about it that water carrying capacity of an air parcel varies with temperature of air. That means a warmer air parcel can hold more amount of vapor as compared to a colder air parcel. Warmer air parcel will be able to hold more water vapor. Why? Because now there is an increased spacing available for the presence of water vapor. Does not mean that warmer air will necessarily have high water vapor content. Please understand, it does not mean that warmer air will have high amount of water vapor. It simply means that it has got the capacity to have high amount of water vapor accommodated. Okay, water vapor and the presence of water vapor is a kind of a sum product of evaporation. In an area, what is the rate of evaporation which happens? How is it that water vapor is supplied into that area? Those are the contributing factors. It can absolutely happen that in a warmer area the air is very dry with no water vapor present. For example, take the case of desert areas. Take the case, for example, of Rajasthan. Now, Western Rajasthan. There, not only will you have warmer air, you will also find the air to be very dry because there is no source of moisture available for the air to be picking up. So that is where it is just the carrying capacity altered by the temperature. Now, this humidity is basically measured by various different types of measurement. That is, how do we calculate that humidity? So we can calculate that humidity in, let's suppose, if I have a parcel of air, if let's suppose I have the parcel of air. Now, if I fix this parcel of air's volume as 1 meter cube, let's assume that this parcel of air has 1 meter cube volume, and I measure the weight of the water vapor included in that 1 meter cube. So that will also give me a measure of humidity. It will give me a measure of humidity in terms of gram per meter cube, right? If suppose I measure the weight of water vapor and I measure the weight of the air molecules also, so that will give me an idea that per kg of air, what is the weight of water vapor which is present. That can also be the measure of humidity. Or suppose I can also have a measurement in the sense that the carrying capacity of air is, let's say, 100, and presently you have 64 units of water vapor present. So it is only 64% of humidity as compared to the carrying capacity. So based upon this, we have different factors of humidity or different types of humidity which is highlighted. So here you have absolute humidity. Absolute humidity is referring to moisture content per volume of air at any given temperature. So that is basically the weight of moisture per volume. So in this, for the measurement purposes, we take 1 meter cube of air as a sample, right? As a fixed sample. And then after that, we end up measuring the weight of the water vapor. So let's suppose in 1 meter cube of air sample, if I have 5 grams of water vapor, absolute humidity can be represented as 5 gram per meter cube. Now we also know that as we move from warmer areas to colder areas, not only does generally the carrying capacity reduce, the amount of moisture present also tends to reduce, because as you move to the colder areas, the amount of evaporation which will occur will also be less. Let's suppose the amount of evaporation which occurs and which is observed in the region of Bay of Bengal, that is nowhere going to be closer to the amount of evaporation which is observed in North Atlantic or North Sea. So that is why also it is essential to understand that when we talk about the absolute humidity, it decreases from equator to the poles, because carrying capacity reduces with temperature, along with the fact that you also have rate of evaporation decreases with temperature. So colder areas, less evaporation; warmer areas, more evaporation will take place. So that is why absolute humidity is basically what is referred to as the weight per unit volume. Here we consider 1 meter cube or any unit volume as a sample. Now, if we are considering the weight of, let's say, the air particles, and then we are comparing it with the weight of water vapor, that gives us specific humidity. So when we talk about specific humidity, it is basically the mass of water vapor per kilogram of air. So both of them are units of weight. So the final specific humidity that you will calculate, there it will not have any unit, because mass and mass, they will cancel out each other. Okay, specific humidity, it gives you an actual representation of what is the water vapor present. Because also consider the fact, let's say when we warm up an air parcel, let's say this is the air parcel earlier, which represents 1 kg. When you heat it up, the air molecules will escape, will expand. So even then, if you have to calculate 1 kg of air, 1 kg, all the particles which had even escaped, that will also be included there. So that is where, when we talk about specific humidity, it is largely fixated, it is largely fixed. That is the case of specific humidity. It doesn't vary very easily with the change in temperature or with the change in volume. It is largely consistent because we are measuring each and every molecular weight here. So that is why it is more fixed, more accurate, more precise in general. But in normal day-to-day parlance, the utility of the measurement of humidity that we come across, that if you read the newspaper headlines, or if you read or if you listen to the news articles, there also you come across the fact that, let's suppose, Kolkata has a humidity of 84%, of 65%, of 70%. Now that is the measure which is referred to as relative humidity. Okay. So relative humidity is basically ratio of amount of water vapor present in the air to what it can carry in total. What is the total carrying capacity of the air at a temperature, and what is the amount which is present as of now. Okay. So for example, let us suppose a certain set of conditions. Let us suppose I have an air parcel. Absolute and specific humidity. In absolute humidity, we consider 1 meter cube of air. In that, we measure the weight of water vapor. Now, 1 meter cube might not contain 1 kg of air. 1 meter cube might very well be around half a kg of air or something like that. In specific humidity, we consider 1 kg of air, right? It is independent of volume, it is mass dependent, 1 kg of air. In that, what is the moisture which is present? That is specific humidity. Okay. Now, suppose we have here the presence of an air parcel. Let us assume that this air parcel's temperature, let's suppose temperature is 25 degrees Celsius. Let's suppose the carrying capacity is 10 grams. Let's suppose the moisture that it is holding, moisture present, is around 5 grams. So in this case, what will be the relative humidity? All those ambitious ones, you have to appear for CSAT as well. Relative humidity will never be in the ratio or decimal. Relative humidity, observe here, this is the image. Relative humidity always expressed in percentage. So it is the moisture present, that is 5 divided by 10 into 100, and that is 50%. It should not take that much time, guys. CSAT paper is anyways becoming difficult with the day. So please don't create a scenario where you are able to clear the cutoff in general studies but are not able to appear for the mains because you have somehow missed on the CSAT. So work on your calculation skills also. Now, let's suppose I heat up this air parcel. Okay. Let's suppose I heat up this air parcel. Now, when I heat it up, temperature, let's say the temperature has now increased to 35 degrees Celsius. Let's suppose carrying capacity has also changed with the changing of temperature. Carrying capacity, let's suppose, has increased to 15 grams. And there is no additional availability of moisture. So moisture present, or the vapor present, let's say, is still 5 grams. What is the relative humidity in this case? Good. Here the relative humidity is roughly around 33% or 33.33% in general. It will not be 66%. Think about it. So it is approximately 33% is something that I can take. Now, conversely, Let's suppose I cool the vapor or cool the air parcel. I cool the air parcel down, and upon cooling, the temperature is from 25 degrees Celsius. Let's say I've cooled it down to 15 degrees Celsius, right? Now, as a result of that, the carrying capacity will also reduce. Carrying capacity, let's suppose, has reduced to somewhere around, let's say, 8 grams. And the vapor present is still the same, that is 5 grams. What will be the relative humidity? So now I'm getting a variety of answers in this case. Whenever you tinker with the denominator, that is where the kind of, see, please, very simple to understand. 5 by 8 into 100. As simple as that. This will come out to be roughly around 62.5%, right? So this will come out around 62.5%. And I have got a variety of answers ranging from 20% to 82% to various different kinds of answers I have got. So all of you kindly work on the calculation once more. So based upon this, we can have a set of conclusions to be made. What are those set of conclusions that we can create out of it? Can we say if there is no additional source of moisture which is supplied, when an air parcel gets heated or the temperature rises in an area, relative humidity reduces. Why? Because the carrying capacity, the denominator, has increased. And can we also say that when you cool the air parcel down, the relative humidity tends to increase because the carrying capacity has reduced, right? We can say that. So heating of an air parcel or heating of air reduces the relative humidity. Cooling of air increases the relative humidity. Is that clear? Any doubts that we have in this particular portion? Any doubts? Good. Absolute and specific humidity, Rahul, is the measure of humidity in terms of any fixed area. If you consider the volume of air, 1 unit volume, 1 meter cube, what is the water vapor present, the weight of it, that will give you in gram per meter cube what is the humidity, absolute humidity. And specific is that in 1 kg of air, when you are calculating the weight of water vapor, that is, so 1 meter cube and 1 kg, both are very different. So that is why absolute and specific. So here, okay, fair enough. Alok, this moisture present also refers to the same thing. So don't get confused here. This also I will do it vapor present. Okay. Now we have seen that even this relative humidity is basically prone to change due to the change in temperature. And this has got an influence on the climate of a place. So that brings us to the concept of saturation of air. Saturation means what? When we say saturation, that means any particular mass or any air parcel, anything doesn't have a capacity to take in anymore. Let's say you have sponge. Now sponges, they are used to mop up excess water which has maybe spilled over a region. Now that sponge, initially it will absorb as much water as it is there. Slowly and steadily, what will happen? It will get saturated with water. Now on top of that, if you start to try to bring in more amount of water or absorb more amount of water by the sponge, it will not be able to do so. And very easily, now that sponge will start leaking water. The sponge which was absorbing water earlier will now start leaking water, isn't it? And that happens when? When the sponge is absolutely filled with water which is present. Something similar happens in the behavior of the air also. When we say saturation of air, that it is that condition when the air parcel consists of as much vapor as it can carry overall. So in this case, there is no additional space for accommodation of any more air parcel. Now, what do you think? In this case, do you think there will be, or what will be the relative humidity of air when the air is saturated? If you have to calculate the relative humidity of air in conditions of saturation, good, it will be 100% because it consists as much vapor as it can overall carry. So that is the condition of a relative humidity of 100%. Now here also, let us consider certain cases. See, whenever you have doubt, guys, let's say after the sessions are over for geography, and this is the normal trend with, and this is the behavior of a candidate, so there is no shame in accepting that. So it might happen, let's say for 4 months you have not touched geography because such has been the trauma created by the subject that you want to approach other areas, you want to study Lakshmikant 5 more times, you will study Hindu 10 more times rather than studying geography again. It can absolutely happen. So whenever that condition happens that after 4 to 5 months you again pick up the subject and you find this portion or any part of humidity, any part of air, or even oceanography which you are unable to understand, always advisable to go to the basics. That is, go to the level of the particles. That how is it that the particles will behave? That oftentimes will give you a much clearer idea about the entirety of the concepts as well. So this is for your long-term revision process. Okay. So here, let us consider an air parcel. Now an air parcel, which is, let's say, at a relative humidity of 100%. So in this case, the carrying capacity, I am representing carrying capacity by Cc. Let's say carrying capacity is 10 grams. Vapor which is present is also 10 grams. Temperature, let's say 25 degrees Celsius. Now, if I were to heat this, heating. Now, once I've heated this air parcel, let's say the temperature increases to 40 degrees Celsius now. The carrying capacity will also increase, isn't it? Carrying capacity, let's say, has become 15 grams and vapor present is 10 grams. So here we have seen that the carrying capacity has increased, right? Vapor present, if there is no additional supply of water vapor, no vapor present will increase. So in this situation, what will happen? The relative humidity will reduce, isn't it? Relative humidity will significantly reduce. So what will be the relative humidity in this case? Relative humidity in this case will be how much? Good. Roughly somewhere around 66%, isn't it? So, a saturated air, when heated, will lead to what? Will lead to the air becoming unsaturated, because now the air will have the scope to accommodate 5 more grams of water vapor, isn't it? So, here, when you have saturated air, upon heating, it can become unsaturated, right? Why? Because the carrying capacity will increase. Let's suppose in the situation where I cool it down, or in this case itself, if you consider an air parcel which is having saturation, it was earlier unsaturated, it had a temperature of 40 degrees Celsius, we cooled it down to 25 degrees Celsius, and then it reached saturation. If I cool the air parcel down further, if I carry out further cooling to, let's say, a temperature of 10 degrees Celsius, now in this case, let's suppose carrying capacity has reduced to 5 grams. The vapor which was present was 10 grams, isn't it? But the air has got the capacity to accommodate only 5 grams. What will happen to the rest of the 5 grams of vapor? What do you think will happen to the rest of the 5 grams? That vapor will not be able to be accommodated in the air parcel. And that vapor, due to oversaturation, will start to condense. And that is what will start to form liquid water droplets. If the temperature is 10 degrees Celsius, it is above the freezing point. So liquid water droplets. But if, let's suppose, the temperature had been -5, -6, it would have formed solid ice particles. So in this case, the vapor which will be accommodated, in the air can only be 5 grams. So what about the surplus 5 grams? It will condense. So surplus 5 grams will condense. Now, that basically means that cooling of air beyond the point of saturation leads to what? Beyond the point of saturation, cooling of air leads to what? It leads to condensation. Isn't it? Because now the air parcel cannot accommodate any more amount of moisture. Here, by cooling, the carrying capacity has reduced to around 5 grams. The vapor which was present in the air was 10 grams. Now you cannot have the case that the total carrying capacity of the air is only to accommodate 5 grams of moisture. Somehow you will have 10 grams that they will accommodate, just like you accommodate in the crowded bus. It cannot be the case like that. Water vapor, when it is in surplus, what will happen? It will start accumulating on the sides in the form of condensates. Now, if saturation temperature is above freezing point or melting point. Simply let me write 0 degree. Condensate will be in the form of liquid water droplets. Condensates will be in the form of liquid droplets. If saturation temperature is less than 0 degrees Celsius, then in that case, what will you observe? The condensate in the form of ice or solid. Okay, so that is what you will observe in that case. That there you will observe that the condensate exists in the form of solid, right? So that is where you have the condition of condensation also coming into the picture. Condensation anywhere will only occur whenever the point of saturation has been reached. Condensation will occur only when cooling of air beyond the point of saturation happens. Only then condensation will occur. So when we talk about condensation, this is something that we experience in our day-to-day lives. We experience in our day-to-day lives in the sense, for example, let's say you put a utensil into the refrigerator, let's say the freezer, for a few hours. You take out that utensil, you keep it out in the open. After a few moments, you will observe that there are a lot of small droplets which start developing around the utensil. Isn't it? You will observe a lot of these small droplets which develop. Have you ever thought about it? Where does that droplet come from? Does that droplet come from inside the utensil leaking on the outside? No. That droplet is a result of condensation. Condensation of what? The air surrounding the utensil. Similarly, let's suppose something that you all would have experienced from your childhood days, you would have experienced that when you would rush to the market during the summer season in order to sneakily get, let's say, a bottle of Coca-Cola or a bottle of Pepsi. Now you would observe that while you are still sipping and enjoying that soft drink, on the outside of it, you will develop that water droplets. They start accumulating. You keep it on a table, water rings formed around it. How and why? So that is condensation. Why does that happen? Let us understand. So here, for example, let's suppose we consider a bottle, any kind of a jar you consider, that you have brought out of the refrigerator. Let's suppose you have brought out a jar out of refrigerator. Now, because this jar was present in the refrigerator, the temperature of the surface, let's say, is 1 degree Celsius or 2 degrees Celsius maybe. Surrounding air, there will be air surrounding it as well. And if you have never experienced this thing, guys, it is high time in your life that you experience this. You cannot have 2 decades of your life lived without experiencing these basic phenomena. So do this thing, that keep or bring a bottle out of your fridge, or keep a utensil or a bottle in your fridge for a long time. Keep it out on the table. And after that, let's suppose here is the bottle. If you bring your hand and palm closer, you will feel that the air becomes colder. If your palms are far away, there is no experience of temperature on your palms. But as you bring it closer to the bottle, you'll feel the air is colder. So let's suppose the air temperature in general, the air temperature at that point is 40 degree, peak of summer or middle of summer. Now here, you will also have an air parcel surrounding that bottle. Now this air parcel starts to cool. Starts to cool down, isn't it? Now, when the air parcel begins to cool down, at a particular point, it will reach the saturation point. Saturation point is what? When the total amount of water vapor present in the air parcel is equal to the carrying capacity. So the carrying capacity has been reduced. We know that by cooling, carrying capacity reduces. So by cooling, the carrying capacity has reduced and it has become equivalent to the temperature or equivalent to the amount of moisture which is present already. So here, air parcel starts to cool down. It attains saturation. Can we say that? It attains saturation, but then it will cool down further, right? Why it cools down, by the way? Because it is in contact with the colder surface. Cools down further. As it is in contact with very cold surface. As a result of that, whatever moisture was present, the excess moisture, in this case, we have seen that you had surplus of 5 grams. They were condensing. Here also, whatever is the excess of moisture, that will condense. So that is where condensation happens on the surface occurs. So for condensation to happen, always you will require a kind of a surface. Condensation can never happen into thin air. Condensation will happen whenever you have a contact with a particular surface which is very cold. So the air very quickly will lose its temperature, attain that particular, let's suppose what we refer to as the saturation point, and will cool down furthermore. So is that understood? That how is it that condensation happens? Whenever any air parcel gets cooled down beyond the point of saturation, condensation occurs. This is the principle behind the formation of clouds. This is the principle behind the formation of dew, frost. Everything is initiated by this simple principle. Heating or cooling cause change in the water vapor, like change in its state only when it reaches oversaturation. Change will happen only when it reaches the saturation. That is when condensation will start to happen. Then will only remaining 5 grams condense? Only remaining 5 grams will condense, right, Shashank? Why the entire of that entirety of vapor? Why will it condense? Okay. How air parcel cooled down to attain saturation? Okay. So we have forgotten the first couple of slides very easily. Take this case. I bring you to the first slide from which we started. Heating of air increases the carrying capacity of air. Okay, what is carrying capacity of air? Amount of moisture that the air parcel can carry at any given temperature is referred to as carrying capacity of air, right? What is the total amount of vapor which is present in an air parcel that it can accommodate in its completion? That is what is carrying capacity. Now, when you heat the air, It increases the carrying capacity. Why? Because the particles, they move away, leaving more space for accommodation. When you cool down the air parcel, it will reduce the carrying capacity. Fair enough. It will reduce the carrying capacity. Carrying capacity means what? Carrying capacity means that beyond a point, you cannot have any more moisture present. So we know that carrying capacity is influenced by temperature, isn't it? Now, here, let me talk about again the basics. If I have the air parcel at a temperature of 40 degrees Celsius, the particles will have some amount of energy in it. So water vapor will be accommodated in between. Here, just by visual appearance, you can gain an idea that the air still has got a greater carrying capacity and still more water vapor can be accommodated in that. We can get a larger idea about that. Let's suppose I cool down the air. Cooling. When I cool it down, let's suppose. So when you cool it down, let's suppose to a temperature of 25 degrees Celsius, let's assume. Now that means more particles will also come in. More particles will come in means what? The particles get closer to each other. The gaseous particles will come closer to each other. Right? Now the water vapor which was present earlier, that can still find some space. But here we can say that the air parcel doesn't have any more capacity to store any more water vapor. Air parcel is carrying as much water vapor as it can hold. Let's take this as the saturation, where relative humidity is going to be 100%. And here, I don't want to explain the entire process of relative humidity again. Let's suppose I initiate another round of cooling. Another round of cooling is initiated. Let's suppose the temperature now is 10 degrees Celsius. So that means the particles will come much more closer to each other as compared to the earlier scenario. They will come much more closer to each other. So whatever amount of water molecules were present, all of that, it cannot be accommodated here. So you will have surplus molecules left, which cannot be accommodated in the air parcel anymore. So what will happen to these surplus air or water molecules? You have the surplus water vapor or water particles. It is this surplus which undergoes condensation. I hope It is understood in that case. Okay? So now, is that understood now? Good. So that is basically the aspect of saturation and condensation. Okay? So now we use this simple process and the simple technique in order to understand the formation of other processes. For example, when we say dew. Now, as I told you, condensation will always happen whenever you have a surface in contact. Because only after getting in contact will the air parcel suddenly start to lose temperature, will the air parcel suddenly start to lose, let's say, the heat which is present in it. So when the air parcel loses heat, that is when it will attain saturation, that is when it will undergo condensation. So here, when you have the condition where the air parcel reaches saturation and beyond that point, cooling happens. So liquid water droplets will develop in case that cooling has happened or that saturation has been attained above 0 degrees Celsius. So furthermore, all the liquid water droplets will accumulate over, let's say, the grasses, will accumulate on the various surfaces, and that is what we have as the condition of dew, right? So when we say dew, so the dew is basically, if you observe on the grasses, on the blades of the grasses, on the leaves of the branches, etc., you will observe that you have accumulation of small water droplets here. So this is accumulated water droplets when the air cools down beyond the point of saturation. Point of saturation. Okay. Now, here, dew point is basically the temperature that air needs to be cooled to, or the air needs to cool down to that particular temperature in order to achieve the saturation or relative humidity of 100%. So if dew point is greater than 0 degrees Celsius, you will have liquid water droplets. What happens if the dew point is less than 0 degrees Celsius? What happens in that case? If the dew point is less than 0 degrees Celsius, then the condensates will be frozen in the frozen state. It is in those conditions that you will find ice forming on the ground surface and on the various surfaces. So if dew point is greater than 0 degrees Celsius, it will lead to liquid droplets. If dew point is attained, let's say at a temperature less than 0 degrees Celsius, then we have frost or ice which develops. So that is basically again a resultant of condensation. But this condensation is happening on the surface. We also have a condensation which happens higher up, and that condensation leads to the formation of clouds. So when we talk about the clouds in general, how are they created? So clouds basically are created whenever you have a rising parcel of air. Always understand that. In any circumstance, cloud will be created only if you have a rising parcel of air. Okay? Always. Always due to rising air parcel. Never due to falling or sinking air parcel will you observe the formation of cloud. So that is why in all the regions wherever you experience low pressure, you will experience the formation of clouds. In all the regions where you experience high pressure, there won't be any formation of the clouds. So why does that happen? So when you have the rising air parcel, as the air rises up, air expands, rises up, it expands. Right? When air expands means what? Cooling occurs. Adiabatic cooling. Now cooling occurs means what? Eventually it will reach saturation. The air reaches saturation. As the air rises further up, means condensation will occur. This condensation can occur even in the case of liquid droplets, even in the case of solid particles, depending upon at what height does the condensation occur. So for example, let us suppose if we have the ground surface, now the air is warmed up near the ground surface. The air then starts to rise up. Now, as the air, let's say the air parcel starts to rise up from here. Now, as this air parcel rises up, it will expand. As it expands, it cools down, rises up further, cools down further. A point will come at a point where condensation will start to happen. When it attains saturation and then rises furthermore, a condensation will happen. But as I told you, condensation can never happen into or out of thin air. Condensation always requires a surface. Nowhere will you come across a scenario that condensation happens out of thin air. So in that case, what is the surface around which the condensation will happen in this case? Very good. Beautiful. It is the dust particles which are present. Remember the entire concept of hygroscopic and hydrophobic nuclei that we had studied? So that is where the dust particles which are present in the air, they present the surface. They provide the surface. So around that surface, you will observe that condensation starts to happen. Now let's suppose ice has and small ice particle has frozen around a dust particle. Now that ice will also serve as a surface. So as more air rises up, more freezing or more condensation will happen around that surface. The particles, they grow larger in size. All these particles, they basically end up forming what we refer to as clouds in general. That is how we have clouds. And this is also the reason why the clouds are present at different height. You will observe that not all the cloud is present at the same height. Clouds are present at a different height. How to understand that? So we'll understand that with the help of an example, a simple example here. Again, I will take. Suppose I give you two conditions. In both the conditions, A and B, the air parcel is rising up. In the case of A, the relative humidity, let's suppose, is 90%. In the case of B, the relative humidity of the air which is supposed to rise is 60%. In which of these cases do you think that cloud formation, I'll launch a poll for this because I want to see who has answered and who has not. In which of these cases do you think that you will come across a scenario that clouds will be formed at a lower height. Which of these will be able to form clouds at a lower height itself? I will launch a poll. Let me know. Where is it that the clouds will be formed at a lower height out of A and B? Okay. Majority of you have given the correct answer, but still not in the majority that I expected. Okay. So clouds are formed when clouds will be created when the air rises up, loses temperature, becomes colder, and that is when you have the formation of the clouds taking place, isn't it? So saturation point needs to be attained. Now, saturation point will be attained earlier in which case? In the case of A or in the case of B? Point of saturation will be attained earlier in which case? Always in the case of A, because the relative humidity is already 90% in the case of A, isn't it? So even if it rises, let's say by 1 kilometer, it might attain a relative humidity of 100% or a point of saturation. Whereas in the case of B, it will have to rise much further to reach the point of saturation. If it rises any further beyond the point of saturation, here cloud formation will take place immediately. But for the case of B, it has to rise furthermore for the cloud formation to take place. That is why in areas of heavy moisture, that is near the larger water bodies, that is seas and oceans, you will come across a very low level cloud in significant proportion. Clouds which are to be found at a very low level itself. Okay. And in drier areas, generally you will come across high altitude clouds under general circumstances. Okay. So that is how clouds are created. That is how clouds are basically formed. Now here, after this, basically, let's suppose a cloud has been formed. Now this cloud is nothing but a combination of many of these small particles. Many of the small particles, they form a cloud. If ever let's say you are moving in an airplane and the airplane is moving through the clouds, these are not absolute solids. Had these been absolute solids, the airplanes would have collided with the clouds, would have crashed there itself. But as the plane moves through the clouds, you observe the very tiny clinkering sounds on the windscreen, isn't it? What is that? It is these tiny particles of ice, tiny dust particles, etc., which basically hits you. So that is the presence of the clouds. That is the composition of the clouds. It is consisted of many, many tiny particles. And these particles are so very small that they are light enough to be held at a particular height. But around a particular particle, let's suppose initially you had the dust particle. Around that dust particle, you had condensation which happened. And that formed an ice droplet. Now this ice particle, it will also serve as a surface for condensation. So more particles will get here. More particles will start to condense, isn't it? Slowly and steadily the size becomes larger and larger. As the size becomes larger, the particle size starts growing bigger and bigger. Why will the particle size grow bigger? Because more condensation will happen around the existing particles. So as the size starts to grow bigger and bigger, they cannot be held within the clouds and they are attracted by the force of gravity. And that is where the small ice particles, they start to fall. Now, as the ice particles are falling, not only will they experience the frictional drag by the air below, they will also experience a higher temperature because the ground surface is always warmer as compared to the upper atmosphere. So as they start experiencing higher temperature, that is when they will melt into liquid droplets. And it is these liquid droplets that you experience in the form of rainfall. Okay? So basically, the air rose up. When the air rose up, at that point of time, it started condensing beyond, when cooled beyond the point of saturation, the particles, the vapor which was present there, that started undergoing condensation. It condensed around the small dust particles. Around the dust particles, that is where slowly and steadily these ice nuclei, they started forming. More condensation will happen around them, because now these ice particles, they provide a larger surface area for condensation as compared to the earlier dust particle. So more condensation happens around them, the size will grow bigger and bigger. Eventually, when the size grows significantly enough, when it can no longer be held in the cloud, that is when it starts to fall. And when it falls, initially it starts its journey as an ice particle, but it experiences higher temperature along the way, and that is where melting happens and you have rainfall. But in certain areas, for example, Jammu Kashmir, Ladakh, Himachal Pradesh, Uttarakhand, Sikkim, some parts of Arunachal Pradesh, we experience snowfall as well. Why is it that we experience snowfall? So snowfall is experienced when the temperature at ground, when temperature of ground is lower than freezing point. In that case, initially, you will have these particles of ice which will start falling. It will melt into rain droplets. But again, as it comes closer to the ground surface, because the ground surface is at very low temperature, it will refreeze into very tiny snowflakes. And snowfall is what is experienced. We experience snowfall. Okay, so this is because the surface is so very cold, air above it also becomes cold, and that is where the rain droplets, they basically freeze into snow particles. That is why we receive rainfall in areas and we receive snowfall in certain areas. Okay, now then we come to the concept of thunder and lightning. Why is it that thunder and lightning occurs, and what is the condition of it? So basically, when you talk about the clouds here, you would have observed that thundering occurs or lightning occurs only when the clouds are very, very thick. In the clouds which are very thin, you don't observe thunder or lightning. So the cloud needs to have the presence of that vertical thickness in order for thunder and lightning to happen. And here also, understand that almost 80% of the lightning occurs within the cloud itself, within from one portion of the cloud to the other portion of the cloud. There, it is only around 15 to 20% of the lightning events which will hit the ground surface. So here you will observe 80% of lightning occurs within the clouds, 20% occurs between cloud and ground. Now, why is it that it occurs? First of all, so for thunder and lightning to occur, you need dense cloud which needs to be present. The cloud density needs to be significant. Its thickness needs to be significant. Now here, you have many dust particles, and around dust particles, many small ice particles are present. Now, whenever the particles, they rub against each other continuously, they interchange electrons, many of them. One will gain electron, another will lose electron, isn't it? So, as the gaining and losing of electron happens, the particles will gain a charge, right? In the cloud, the particles, they are consistently moving with respect to each other. So they will be consistently rubbing against each other. That is where they will be developing a kind of a charge. So that is where you will observe that different portions of the cloud, they develop different types of charge. They will develop different types of charge. Okay. Now, charge flows between, from what? From negative to zero in general, or negative to positive. That is where the charge is going to flow. So here the charge will flow. Significant charge flows, causing a kind of a lightning event. Here also, let's suppose there is a significant development of charge, lot of accumulation of charge. Charge will flow from negative to zero. Ground is considered to be zero, isn't it? Ground is considered to be zero charge. I hope we are aware of this basic fact. So ground is considered to be zero charge. So that is why you experience lightning events on the ground. Now, this is where, if, for example, let's suppose I have a tree in the middle of nowhere, in the sense that I have no other protrusions from the ground, no other construction, or no other variation on the ground. I just have the presence of this tree. So this tree will be like an extension of the ground surface in a larger area. This tree will also signify zero charge. So that is why if you have one tree or a few trees in the middle of an absolute nowhere, or no other tall buildings, etc., nearby, the charge directly falls on the tree and the lightning strikes the tree. That is why it is advisable that in the cases of heavy rain or dense cloud, it is better to get drenched in the rain rather than taking a shelter in the tree. And people take shelter underneath a tree for protection, that we will be protected from the events of rainfall. But trees are those places where the lightning will strike, right? Wherever, whichever incidents of lightning that you come across, you will observe that around a tree or on a tree, and people taking shelter underneath it, they have been suffering, or they have experienced the worst of it. Why is that? Because exhibits a kind of a zero charge. It is a simple projection of that zero charge which is present on the ground. That zero charge is projected upwards. Okay, so always better to get drenched in the rain rather than going for taking a shelter. Every year during the time of the rainy season, you have hundreds of people who lose their life, especially in the agricultural states of eastern UP, Bihar, West Bengal. And why is that? That is because in many of these, you will find you have large farmlands. And in between these farmlands, let's say you have a couple of trees. So all the people moving around, passing from that region, working in the fields, they will take shelter underneath the tree. And they are not aware that the charge will fall upon them. And that is where myths, they start to flow. You have a lot of myths around thunder and lightning, that lightning strikes if you wear a dark colored cloth, then lightning will strike you. If you wear this kind of cloth, or if you, let's say, you have not worshipped in the morning, then lightning will strike. all these myths and fallacies, they are bred or they come into existence because of lack of knowledge, lack of information, and unawareness in the simplest of the terms. Okay? So that is basically why you have lightning events which occur. Now, why is it that we experience thunder? The thunderous sound that you hear. Why is it that we experience that? So that thunderous sound is basically ascribable to the air around, the air in this region. The air that is present in this region. Now, in this area, in the immediate vicinity where the lightning has occurred, now, whenever lightning occurs, you have excessively high temperature which is attained, very high temperature. Temperature and even the amount of voltage which is passing through, that basically is in the range of a few thousands of volts in general, many kilovolts, 11 to 12 kilovolts on an average is supplied in a very short time period of milliseconds when a lightning event occurs. So when you have that high amount of charge which is passing through the air and in a very short time duration, what happens? Temperature suddenly rises in that immediate vicinity. For a brief time, the temperature rises suddenly. And when the temperature rises, how does the air behave? Air tends to expand. Now, when air expands very suddenly and very violently, it is at that point that it emits that sound which we hear in the form of thunder. So, thunder is caused because of sudden violent expansion of air around the region of lightning because of very high temperatures attained momentarily. Okay, so that is why here we experience thunder. So, temperature rises suddenly, due to which you have what? Air expands violently. As the air expands violently means what? Creates thunderous sounds. Okay? So, this event of thunder and lightning can occur anywhere and everywhere, but mostly you will observe that lightning events are restricted within the clouds. Very few of them are basically between the cloud and the ground. And even when it hits the ground, sometimes it can hit the trees, sometimes it will target the tall buildings, right? It might even target the tall buildings because even the tall buildings can be the projections of the zero charge that is present on the ground. So that is why it is always advisable that in case of tall buildings, you should always have lightning conductors and lightning arresters. The entire concept, I'm sure you would have studied in your maybe class 7th or class 8th science when it is covered in the basics. But still, this is something that you need to understand for the portion of geography also. So it is a mere revision of what you have done in your class 6th or 7th standard. Okay. How does the thunder strike in the tree which causes fire? Thunder strikes in the tree because it is lightning which strikes. Thunder doesn't strike. Lightning strikes because of movement of charge. So if this is zero charge, ground is zero charge, tree is also considered to be a projection of zero charge. That is why it attracts. Yes, Ashwan, that is correct. Ground was zero charge, then how can we stand outside on the ground? What? If the ground was zero charge, then how can we stand? See, for us, Are you confusing charge with gravity? I hope you are not doing that. Charge is the existence of charge has got no role to play whether you are able to stand on the ground or not. Is that what you were getting confused with? Okay. Hmm. I will assume that you are confusing charge with gravity for my own mental sanity. Okay. Otherwise, that is very perplexing. That if ground is, you will be able to stand in areas where there is zero charge. Charge is what? Electrons, protons, neutrons, atoms, molecules. You would have heard about that. That is basically charge. Just a brief moment. Just a moment. So now we come to the types of clouds that we have. So overall, based upon their height, you have the various different types of clouds, the classification of clouds. In general, when we talk about clouds, there are few basic types of clouds. For example, we have the aspect of, let's say, the clouds. You would have observed sometimes that the clouds are basically layered. And in a single layer format, it is stretched over. So these kinds of clouds, they are referred to as stratus. Again, taken from the term strata. So these are what are referred to as stratus clouds. Then another case is when you have, let's suppose, a cloud which will give you an idea as if it is a heaped up ball of cotton, an accumulation of sorts. This kind of cloud is referred to as cumulus. Right? So these are very basics of them. Then the clouds which carry rain, which bring rain, they are referred to as, in general, nimbus clouds. Okay, so the clouds which bring rainfall, they are referred to as nimbus clouds in general. Okay, so here, all the classification of the clouds that you see, you have overall 10 different kinds of clouds. Now, overall, many of the candidates, they do is they learn all of these, but that is not needed. The clouds are named based upon the height that they are formed at, that they are attained at. So for example, when we have the high level clouds, these are what are referred to as cirrus clouds. So if you have the presence of stratus in high altitude, cirrostratus. So you attach the prefix of cirro. If you have cumulus in high altitude, attach the letter or the word cirrocumulus. So that is why high altitude clouds, cirrocumulus, cirrus, cirrostratus. Stratus and cumulus, you observe, is a common factor here. Then when we talk about the middle altitude clouds, the mid-level clouds. Now these clouds, here you will attach the prefix alto. So you have altocumulus and altostratus. Now the low-level clouds independently stratus, cumulus, and stratocumulus. Stratocumulus you will observe having a kind of a flat base. And a kind of a accumulation on top. So it will have a condition of both the stratus as well as cumulus. Right? So stratus always will appear in the form of layers. Cumulus always will appear in the form of accumulations in general. So that is where low level cloud, stratus, cumulus, and stratocumulus. And you also have multi-layered clouds. The clouds which extend from very close to the ground level to a greater height. So those multi-level clouds, they are classified as nimbostratus and cumulonimbus. So all this classification is done. Why is it referred to as low level clouds? The height is low. Why is it referred to as mid level clouds? Because the height is in the middle terms, right? 3 to 6 kilometers from the ground surface. So take a look at all these cloud formations and the cloud classification. So if it is formed at higher altitude, that is where you will have cirrocumulus, that is where you will have cirrostratus, and that is in general where you will have cirrus as well. Then the middle level clouds that you have altocumulus. Observe, cumulus is in the form of the accumulations, right? Stratus is in the form of linear layering of sorts. Okay, and then low level cumulus, you have stratocumulus, and then you also have stratus. And then you have the multi-layered clouds, which extend for many, many layers. Cumulonimbus, nimbostratus. Okay, both of these will bring adequate rainfall in general. In general, cirrus and or cirrocumulus, cirrus and cirrostratus, along with the alto level, they will never bring you rainfall. It is the rainfall that we receive is either brought by the low level clouds or the multi-layered clouds. Okay, these high altitude clouds and mid level clouds, they rarely will bring you rainfall. And what is the reason for that? Because the height is so significant. By the time that the water droplets they start to fall, many of the times it will re-evaporate before reaching the ground surface. So that is why, while it will increase the rate of heating, because the water vapor will trap heat, here it will not have the condition of significant rainfall caused. So generally, under general circumstances, cirrus or cirro level clouds and alto level clouds, they won't bring rainfall. It is the low level and multi-layered clouds which will bring rainfall. Okay. Now here, when we take a look at few of these cloud types, so basically when we talk about cirrus clouds, they appear like this in the sky. They appear as if I'm sure all of you have observed this, they appear as feathery, wispy kind of formations. Okay, feathery, wispy formations made up of very small ice crystals. And they are often colored, so basically they get influenced by the refraction of light. Because they are at such great altitude, you would have observed sometimes or experienced that the cloud in itself exhibits a reddish coloration pattern, a yellowish coloration pattern, etc. That is because of refraction of light. They are at very high altitude. Generally do not bring rain. Do not cause rainfall. Okay, so these are your cirrus cloud. Observe here also how the light interplay is happening, creating a kind of a rainbow effect. So that is where these are very fine, feathery, wispy formations. When we talk about cumulus, this is what the cumulus clouds they appear to look like heaped up balls of cotton. In certain areas, they can bring about rainfall. And wherever evaporation happens, as a process of condensation, these cumulus clouds are created in the process. Okay, so cumulus clouds are a result of the process of condensation which takes place. It is generally puffy, thick, right? Puffy in nature, significantly thick. That is a characteristic, looks up like heaped up cotton in general. And it is found everywhere across the planet almost, except the polar region, because polar region the temperature is so low, evaporation is absent in the polar area. When we talk about stratus, so sometimes you would have observed that there is a cloud covering. You are not able to observe the blue sky, but it is whitish or significantly bright cloud. where you get an idea that the cloud is not very thick. If the cloud would have been thick, you would have gotten up an appearance of black color. So the cloud is not very thick, but it is spread over. That is stratus. So that can cause very light drizzle, right? Sometimes you observe that with the passage of the wind, sometimes very tiny droplets they hit your face and they continue for some time. What is referred to as drizzle. So that is caused by stratus cloud. In stratus, you won't experience thunder and lightning, majority of the cases. Stratus, you will observe the bringing of light drizzle and it will clear up within some time, or it might lead to development of much more denser clouds going ahead. For example, you can have the formation of this kind of a cloud which you observe, that is nimbostratus. Now, when we have nimbostratus here, when we have nimbostratus, basically it is very, very thick here. And within it itself, it can have a kind of a cumulus cloud also to be formed here within itself. It can have a cumulonimbus cloud included within that. So here, observe wherever the clouds will be very dense, very thick, in these regions, the cloud will appear very dark, blackish almost. And then there will be bright portions, means the cloud is thinner in this area. Here you will observe a lot of cloud to cloud thunder and lightning events taking place. And here, these will bring again moderate rainfall for a very prolonged duration. Whenever you come across this kind of a cloud, understand that the rainfall will be present for a very long time. You would have come across scenarios where it might have started raining around 2 p.m. in the afternoon and it continues to rain till 8 p.m., 10 p.m. at night. Or it has started raining at 7 p.m. in the evening, it continues to rain early in the morning till that point of time. That is the work of nimbostratus cloud. So whenever you have or you observe a nimbostratus cloud, make it a point that you reach your destination, because especially in the urban areas that we have now, so you might never know that the region might get flooded, because if it rains continuously for 3 to 4 hours, you never know what might be the outcome of it. So it significant causes prolonged spell of rainfall. Okay, then we have the most violent of all the cloud types, that is the cumulonimbus. It can extend for many kilometers. Now, because of the significantly vertical development, a significant intensive vertical development that it has, this will bring short spells of very heavy rain. You have the conditions of very heavy rainfall where nothing is visible, large droplets they fall, right? Thunder, lightning, they will be very consistent. So that is something which you will observe in the case of cumulonimbus. But here, whenever that rainfall will occur, it will give you that brief moment of time for around, let's say, it will give you that brief window of 1 hour or 2 hours in between after the rainfall, that you will have a clear moment where you can rush home or move around. So always advisable when you see these dark clouds, very dark cumulonimbus clouds, always advisable, take shelter, because thunder, lightning, very heavy rainfall will accompany. And beyond, after 1 or 2 hours, it will ease up and then it will give you the passage of movement. So this is basically the characteristic of various different types of clouds that we have. Then we have the event of cloudburst, and then we will take a look into what is it that we refer to as hailstorm. So first of all, when we talk about cloudburst, the name in itself suggests that the cloud in itself virtually almost opens up. That is a cloud burst. So this will happen when the cloud becomes so unsustainably large in size that it cannot hold its own weight, and everything which is contained, it simply gives way and drains out. So here, for the occurrence of cloudburst, you do require the clouds to become unsustainably large in size. Right? Happens when they become unsustainably large, unable to hold their own weight. Mostly observed over hilly areas. Observed over hilly areas, hilly regions, can sometimes be experienced over plains. So why? Why will the clouds become so unsustainably large that they are unable to hold their own weight? Won't they start bringing rainfall before that itself? So that is because of many of the times prolonged wind movement. Understand? For example, in a hilly region, let's suppose in a hilly area. Now, moist winds are moving, especially during the monsoon months. Now, moist winds, they come in large numbers and they basically are a continuous phenomena. So these winds, they will be forced to rise up, they will lose temperature, they will form clouds. Now, more winds will come up, more winds will rise up, cloud grows larger in size. More winds will come, more winds will rise up, will be forced to rise up, cloud becomes further larger in size. It keeps on growing bigger and bigger. Now let's suppose, in this case, if you consider, after a point of time, the cloud is so very heavy, it is kept aloft, it is kept in that position only because of the wind movement and the support that the wind is able to provide it. That is it. Otherwise, the cloud would not have been in existence at that region. Because the wind is continuously blowing and the wind is able to hold that weight of the cloud. Now, if consider, even for a briefest of the moment, let's say half an hour, let's say even for 1 hour, you have this wind which goes absent. It becomes discontinuous, even for 1 hour. What will happen? All that moisture which was held, all that moisture will suddenly be dropped, and you will have the entire unsustainable size of it that will drop immediately, because now you don't have the winds to carry them. Now everything will be dropped significantly, and that causes cloudburst. Okay, so for example 15th of June this year, it will mark the 10 years of the very tragic Uttarakhand tragedy, in a sense, which happened across Kedarnath. Now that happened because of this cloud burst. That is why during the later end of the rainy season, you will experience these cloudburst events to occur in many, many parts of Uttarakhand, some parts of Sikkim, some parts of Arunachal. In the later portion of rainy season, you do experience those events. So that is why, and that is how cloudburst occurs. Now, when the cloudburst occurs, it will bring a lot of rainfall in very short duration. When a lot of rainfall is brought in very short duration, that floods the region immediately, because the ground doesn't have the capacity to absorb that much in a short time duration. And that is where it will end up causing flash floods. Where sudden occurrence of flooding also is experienced. Now, this can happen over plain areas also. For example, due to intense, here the image that you see is actually of a cloudburst happening over a plain region. So if you observe, sometimes what happens over a plain region, due to excessive amount of heating, there is a development of a very intense low pressure over the plain area. Very intense low pressure. So the winds, they continue to rise up, and if the winds are moist, they will carry a lot of moisture. They will make the cloud unsustainably large. And if the winds, even for a brief duration, if the winds, let's say, they become absent or discontinuous, all that which was present, that will simply start to fall. So it can also happen over a plain area. But in majority of the cases, 90% and more of the cases, it will happen in hilly areas. Why? Because in the case of the hilly areas, that natural lift is provided to the air. Because of the slope, air rises and air is forced to rise naturally. It keeps on losing temperature, keeps on forming cloud, and that is how cloud bursts, they tend to occur. Okay? So that is where we'll restrict it. We'll take one question for discussion, the previous year question, and then we'll end the session. So the question is, which one of the following statements is correct? Cirrus clouds are composed of ice crystals. Cirrus clouds have a flat base and appear as rising domes. Cirrus clouds are white and thin and form delicate patches and give a fibrous and, or here you have cumulus clouds are white and thin and form delicate patches and give a fibrous and feathery appearance. And cumulus clouds are classified as high clouds. Which of this is the correct answer? Good, Priyanka. Palak incorrect. Kishan correct. Anjum, Femina, Nirbhay, Vivek incorrect. Auroras are not formed by the clouds. Auroras are formed at a very high altitude. Clouds are formed at low altitude. So good. A majority of you somehow have that is a small majority, not a large majority. So, but a majority of you have given the correct answer, a thin majority that is. So, cirrus clouds are composed of ice crystals. Cirrus clouds are very high altitude clouds. So, there will be ice crystals in that region. So, do you find any argument by which you can say that the first statement is incorrect? No. So, let's keep that in dicey portion. Second statement. Cirrus clouds have flat base and appear as rising domes. Which cloud has flat base and appears as rising domes? You have stratocumulus. Stratocumulus. That has got a flat base and a rising dome. Then cumulus clouds are white and thin and form delicate patches and give a fibrous and feathery appearance. Which cloud is being talked about in this case? This is incorrect. Here we are talking about cirrus clouds. Cirrus clouds have these features. Cumulus clouds are classified as high clouds? Absolutely not. Cirrus are classified. So that leaves us with the first statement. First statement is going to be correct. Okay. So now, yes, cloudburst is also very famous and very frequent in Jammu Kashmir as well. Okay. Now let me take a few questions. So that is where we will end the session here, guys. Okay. So if you don't have doubts, you can then leave. I hope the session was helpful. Tomorrow we will continue with the rest of the portions. Okay. Shashank, don't the buildings have zero charge? Yes, my dear friend, buildings will have zero charge. The buildings have got zero charge. That is why in case of the tall buildings earlier, what used to happen was there will be a lot of lightning events on these buildings, and many people would get impacted by it. That is why the concept of lightning conductors came in. That is why eventually the design of the buildings started happening in a way where on top the building would get curved or would have a projection, and on top of that you would have a very long and a straight towering lightning conductor. The purpose is to arrest that lightning, to attract that lightning to its place, and then to return it to the ground surface. Okay. Is there any chance of lightning directly hitting us? No, it is absolutely rarest of rare. Suppose the lightning was supposed to hit the ground in a region, and you are that lucky an individual that you have just walked on that region, then yes, lightning can strike you. Otherwise, no. And that is where I am telling you that all these myths have come in. Why negative charge at the bottom of the clouds, Pulkit? See, it is a concept. I didn't want to get into the depth of it because many of the times when basics itself is very dicey, it is a bit dangerous to elevate the level of concept. So, if you are ready to understand that, I'm ready to explain it to you. So, provided you increase your capacity. So, think about it. How is it that charge is developed? When particles they rub against each other, charge gets to develop. Now, in a thick cloud, we have said that charge develops in and lightning happens when you have a very thick cloud. Now, basically, here you will have a lot of particles. Now, suppose any of this particle starts to drop. It will rub against the other particles. It will gain their electrons, right? So, when you gain electrons, what happens? You develop a negative charge. And the atoms which have given their electrons, they will be left with positive charge. And as this particle goes ahead, it strikes, it carries on building that negative charge, and all around it, positive charge develops. That is why you will have such greater density of positive charge. And then eventually, all the particles, as they are falling, where will they accumulate? In the lower portion. That is where all the negative charge will be present. So that is why in the lower portion you have all the negative charge, and that is where even within the clouds, negative to positive, when it flows, it is from bottom to top. That is why. Is that understood, Pulkit? Can stoppage of air be taken as an indication to vacate that place? Yes, but then that is for a very brief duration, right? That stoppage of air can be for a few hours, and you don't get an idea about just by looking at the ground surface that how big that cloud will be. It is with the help of Doppler radars that a prediction can be made particularly easier. So that is where you have the weather prediction coming into place, and that is where the weather prediction failed us during on 15th of June 2013. And if you believe the weather officials, they had circulated that notice, but that notice reached the government offices after 5 p.m., and the government officials had the argument that who works after 5 p.m., so we didn't take care of that notice. So automatically, if for 2 to 3 days that rising of air is happening, it will lead to very dense cloud. There is a probability of high amount of cloud burst happening. Can we say no lightning means no thunder? Yes. Where the lightning comes first, tree or building, anywhere it can come. It is dependent on that region, the landscape, etc. Why zero charge for the ground? That is because when you consider the ground is consisting of many different materials and a larger substance where the movement of electrons, protons, that can happen in an easier way. Ground will never exhibit, or the planet in general will never exhibit a set charge, because no charge is being drained away or is being continuously accumulated. That is why and it is a very large space as well. That is why even if a charge develops in an area, it has got ample space to dissipate itself. That is why ground is always considered as a zero charge. Cumulonimbus clouds, the top of it can be at high altitude, the bottom is at very low altitude. And can we avoid cloudburst by sprinkling water repellent nuclei? Absolutely, yes, you can. And then Lakshmi, if rainfall occurs with lightning, then how temperature of air rises near that light? It will remain cool. No, no, absolutely not. I'm not saying that entire air temperature will increase. In that minutest of the portion through which the lightning passes, right? So you have the transient time, very small time window of millisecond, nanosecond. For that milli nanosecond in that vicinity area, imagine you have 11 kilovolt, 12 kilovolt of charge which is moving, voltage which is moving. That is very, very high. So that is why in for that brief duration in that region, suddenly there will be excessive heating and hence it will suddenly expand. Yes, Rahul, that is correct. It means warm advection has high probability to bring precipitation. Yes, in many of the cases. But not always. See, warm advection, what it can also end up doing, you have to understand this carefully, is warm advection will also end up increasing the temperature of that region, lowering the relative humidity. So it might make rainfall much more difficult. Cold advection, on the other hand, will reduce the carrying capacity of air, and that can bring precipitation. Yes, Kishan, I will give more mapping work tomorrow also. In saturation point, when surplus moisture is made out, is it readily liquid or becomes liquid after interacting with dust particles? So think about it. Very simple. Think about, let's say the palm of my hand is a dust particle. Now the moisture which is present around. Now this dust particle or palm of my hand, when it is higher up, it will be at very low temperature, very, very low temperature. Now, when the air droplet comes in or the water vapor comes in contact with it, if the temperature, let's say, is below freezing point in that case, and the air has reached saturation, it will freeze into an ice particle. Vapor will directly freeze into an ice particle. Otherwise, vapor will get converted into a liquid droplet. Same in the case of dew also, dew and frost. If the saturation temperature has been reached at, let's say, 4 degree, 5 degree, or even 20 degrees Celsius. Now, when coming in contact with that 20 degrees Celsius surface, that is when vapor will convert into liquid droplet. Okay? I hope that is understood. Raghav. Lakshmi, charge at bottom basically, okay. So think about it that you have particles which move against each other, that they rub against each other. When they rub against each other, charges. So every particle is made up of molecules, every molecule is made up of atoms. So when the atoms, they rub against each other, electron is gained and lost. So generally when you have a particle moving from top to bottom, it will keep on gaining the electrons with all the particles that it is rubbing against. That is why overall at the bottom you have negative charge accumulated. Then as ground doesn't have a charge, how water contains charges? Where, Abhishek, where did you see that water contains charges? And it means in case of snowfall, temperature inversion is in existence. In certain cases, yes, surface inversion is in existence. If temperature increases, while the moisture content stays the same, the relative humidity decreases. Yes, Rahul, correct. Anjali, is it concept of artificial cloud where we have no rainfall, try take help of. So artificial cloud is basically what is also referred to as cloud seeding. That is where what we talked about in module 6 itself. When you, let's say, you don't have enough dust particles, you have evaporation happening, but the cloud formation is not happening. So with the help of an airplane, you discharge materials like silver iodide, and they start forming the nuclei around which the condensation can take place. So there you have the artificial clouds. When vapor is repelled by the dust particles, in that case, cloud formation doesn't take place, Ravindra. Orographic we will study tomorrow. So that is where we'll restrict the session here today, guys. We meet again tomorrow where we continue with the portion of hailstorm and the types of rainfall. And then after that, finally, we get into the area of air masses and cyclones. So that will be all from my side today. See you again tomorrow. Take care of yourself. Goodbye. Thank you.